First, we stop the simulator, set it. Press start. In order to see the trending much better, we zoom in the scale to 30 seconds. Okay. First is we need to eliminate the integral and derivative action. So how to do it is put this one to maximum value 1000, derivative already 0. Okay. So we've done this. Then next step is to set the controller again to 1 or less. So it's already 1. Okay. Then we set the controller in auto. Okay. Then next is increase the gain until there's a sustained oscillation. Okay. So increase the gain. So you don't see any change because the PV is same as set point. So we need to create a bump. So you can see the overshoot actually die off, is overdamp, not yet oscillate. Oscillate means that the overshoot is the same amplitude. So we continue to increase the gain. Okay, then we bump again the set point. So you can see the next amplitude overshoot start to. This one is also start to reduce, so it's still overdamp. So we need to increase more. 7. So create another bump again. So now you can see it start to oscillate because the amplitude for each overshoot and undershoot is the same. There's a sustained oscillation. So now the next step will be, we've done this already. Done this already. So we reduce the controller gain by a factor of 2. So the controller gain is 2.7 divided by 2 is 1.35. 1.35. Okay, so the sustained oscillation is no longer there. Next is, we've done this. Add integral action gradually until we see the sustained oscillation again. So now we change the again. So we change to 10. So we need to pump the set point. Still no sustained oscillation, so we need to reduce the integral. To 3. Create another bump. Nope. Still no sustained oscillation. Go to 2. Create another bump. Nope. Go to 1. Nope. No sustained oscillation. Go to 0.6. No. Now we go to 0.3. No. 0.1. No. Now let's go to 0.4. 0.4. Nope. Then let's go to 0.02. All right. So it start to have a go out of control. So means that just now we put in too much. So we go to 0.03. Okay. So it's about there already. We got a sustained oscillation. So we set the integral time 3 times of this value. So 0.03 it's become 0.09 3 times. Okay. So the oscillation stopped. So done this. So now if required, so say for example, if we want the derivative action required as well, we can do the same. Add the derivative action until we got a continuous oscillation, then we divide by 3. So for this exercise, we only want a P high. So now let's see the response. Maybe it's blue. Okay. So if we are happy with this response, then this is already considered acceptable.